Okay, Assalamualaikum and good morning. Okay, so I hope you already watched the previous video. Okay, so you learn about the anatomy of the wind turbine. Okay, and also the mechanical part of the wind turbine. So now we continue with the next part, which is electrical component. Okay, so after this, most of the learning is more towards the theoretical part. So the calculation is very simple, like I showed before. Only two equation that you need to know. Based on that equation, there are various question that can be asked. Okay, so for the theoretical part, which is around 25 out of 100 for the final exam, so it can come from any part of the theoretical part. Okay, so this is the summary of the electrical component in the wind turbine. So I will show you the generator, okay, the generator concept, the speed, application, and the machine type. Okay, and then for the second part is the wind turbine system type. You have type 1, 2, 3, and 4, or type A, B, C, and D. So depend on you lah. Some question ask you type 1, or some question ask you type 1 or type A lah. Okay, so it's the same thing. Okay, and next is the power converter. You learn about power converter use in the wind turbine. And lastly, the maximum power point tracking, similar to the PV. Okay, PV has MPPT, maximum power point tracking. The wind turbine also have the MPPT. Okay, so there are two types, either turbine parameter MPPT and iterative MPPT. So in the PV chapter 2, it is offline and online, but in this chapter 3, it is turbine parameter MPPT or iterative MPPT. Okay, so this is the wind turbine. Okay, so you have a wind rotor here, and then gearbox. This is optional, depend on the system. And then you have a generator, and then you have a power converter, and you have transformer, and then to the grid. Okay, that is the standard of wind turbine. Okay, so for the generator, there are four types usually used, either EEGSG, electrical excited synchronous generator. Okay, so or permanent magnet synchronous generator. These both are usually gearless, no need to use gear. And then you have gear types, which is either squirrel cage induction generator and double fed induction generator. So this one usually needs to have gear because it's need to rotate at a very fast rate lah, usually. Okay, so that is four types of generator that you need to know. Okay, so what is synchronized generator? Okay, synchronized generator, stator directly connected to the grid. Okay, the stator, the non-moving part, is directly connected to the grid. Okay, so I think this one have some wrong. I think this is not synchronized generator also, number 2. Let me check later. Synchronized generator is directly connected. Stator is directly connected to the grid, and rotor consists of a short circuit copper bar squirrel cage. So this is not synchronized generator. This is induction motor. Okay, make sure you repair it. I will repair it later. Okay, when rotor speed exceed the synchronized speed, this operate as generator. Basically, to operate as a the synchronized speed is the frequency speed of the grid. Okay, synchronized speed is the speed of the grid. For example, it is for in Malaysia is 50 hertz. So it become 3000 RPM, right? Okay, 3000 RPM. So for 3000 RPM, to operate as generator, the induction motor needs to operate faster than that, from 3000 RPM, like 51 or 52. Then it become synchronized generator. Okay, and then require reactive power from the grid. Okay, simple, robust, and low cost, but limited speed control and lower energy capture. So that is the limitation lah. Okay, so it cannot be very high lah. The speed different, the induction mode, the speed cannot be more than the synchronized speed, and because of that, it's very hard to capture energy, especially at low energy capture, because the speed needs to be faster than the synchronized speed. Okay, next the synchronized. So this is the unsynchronized. So this is the synchronized. Okay, so synchronized generator operate at a synchronized speed with no slip. So this one have slip. So rotor excitement provided by permanent magnet or DC excited copper winding. So this one, okay, this one you have to excite the rotor lah, and permanent magnet of course no need lah. Okay, so based on this, well suited for variable speed and lower speed wind turbine, often used in direct drive system, eliminating the gearbox, high efficiency and excellent grid support capability. Okay, so this is two types of the commonly used wind turbine generator, and this is the future concept, which is double fed induction generator. Stator is directly connected to the grid. Rotor is connected to the grid through slip ring with power electronic converter. Allow variable speed with small converter rating 30% of the power generator. So basically, you have more better control, okay, compared to the unsynchronized generator lah. So this one is much more better in the speed operation. Okay, provide control of active and reactive power, widely used, but the slip ring increase maintenance requirement, because it requires slip ring. It has problem lah, a bit problem. Okay, so I hope that is clear on the generator concept. Make sure you correct this one if not mistaken, unsynchronized generator. Okay, so next is the next part, which is fixed speed application and variable speed application. So what is fixed speed application? Is generator is mechanically coupled with the wind turbine, is directly connected to the grid utility. Okay, so basically this is an old method which require the wind turbine to operate at a fixed speed. Okay, so at a given point, the rotor has a fixed speed governed by the frequency of the utility. Okay, if grid is 50 Hz, the generator rotate at 30,000 RPM single pole, or double pole will operate at 1500 RPM. Okay, so this is the generator speed, not the rotor speed. Okay, that's why you need a gear for this to adjust the generator speed. Okay, so since the wind speed is not constant, keeping the generator speed constant is difficult. Gearbox is needed to maintain the constant speed, resulting in severe mechanical stress. So actually this is an old method. Okay, so the new method, usually we use a variable speed application lah. Capture maximum wind energy compared to the fixed speed operation. Instead of directly connected to the grid, variable speed configuration are connected to the grid using power electronic. This is the most common type of generator used in the induction and synchronized generator. Okay, so this is the comparison lah. So better to memorize it. Okay, so this one already explained. Rotor speed also already explained. So this one already explained also. Already explained. Okay, already explained. Okay, most of it already explained. Okay, efficiency, of course, fixed speed has lower efficiency and variable speed has higher efficiency. Cost, lower initial cost. Okay, high initial cost. This one is more older or small wind turbine, dominant in a more large scale turbine. So most of it are already explained, and this is just a summary of what is the explanation given before. Okay, so that one I hope is clear. So we also have a machine type. So for the machine type, you can see here, this is the machine type. Okay, okay, so you have a induction machine. This is commonly used. For this class, no need to worry. You don't have to know everything lah, because this is from electrical machine. Okay, you already learned this in electrical machine. This one is basic of the induction machine. So you know that induction machine, the rotor can be either wound rotor or squirrel cage rotor. So this is a non-synchronized, okay, type lah, because you need to have slip to operate. Okay, so this is the equation of the slip. Okay, if the W is the synchronized speed and WR is the rotor. So of course, like I said before, to make it as a generator, the slip, the wind rotor speed needs to be higher. Okay, so this is a single fed induction generator wind turbine. So you can see here, this is single fed. Okay, you have to be careful. There are single fed and double fed. Okay, so single fed is basically you connect the stator to the grid. This is the grid. So this one is single fed induction generator. Okay, so this is the more advanced, which is called future double fed induction generator wind turbine. Why is called double fed? You can see here there is a 2 time fed. Okay, okay. So the first one is from the this is at the rotor. Okay, so at the rotor here, the system, the generator is directly connected to the grid. That is for the stator. Okay, but for the rotor you have a what you call a cycloconverter here. So what it means by cycloconverter, you have an inverter to become rectifier, become DC. The grid is AC, become DC, and then DC become AC back. Okay, so this one, like I said before, double fed induction generator will have better control. Okay, you have better control, almost 30% of the speed compared to single fed. If not mistaken, only 1 to 5%, if not mistaken. Okay, so this one have better speed control. Okay, so this one, double fed induction generator, advantage lower converter rating, which reduce the cost. So this converter is usually much more smaller lah. Okay, around 30% only. So smaller converter rating means that smaller cost. So good efficiency and controllability, like I said before. Controllability, small and light generator, because you don't have permanent magnet, right? As a result, it's much more light. Okay, so there is a disadvantage, also require gearbox, needs maintenance, because it cannot fully control the speed, only 30%. Okay, and then an increased gearbox loading during fault. Okay, if fault happen, you can damage the gearbox. Need different gearbox for different frequency, of course. And speed control only 30% of the synchronized speed. Slip ring, increase maintenance. You have a slip ring, you have to maintain it, and gearbox also you have to maintain it, and it easily broken. Limited speed range compared to the full converter, and weak fault ride through the capability. Okay, so basically this is the disadvantage lah. Okay, so synchronized generator. Okay, this is no need to worry too much on this. Basically, the speed of the rotor is the same speed of the grid. Okay, so this is permanent magnet. Also, we don't focus on this, so no need to worry too much on this. Okay, so this is the important things. The advantage of the synchronized generator. This is the permanent magnet synchronized generator. You don't have gearbox. Usually don't have gearbox. No rotor excitation loss. Okay, no need to excite the rotor because you have used permanent magnet. Excellent power quality and grid support. Full decouple from the grid. Wide range speed operation. Low operational and maintenance cost, because you don't have the slip ring, you don't have to maintain it. Also don't have the gearbox, you don't have to maintain it. And also smaller in size. Okay, so usually permanent magnet are smaller in size, but the disadvantage is high converter cost. Okay, use a rare earth. Okay, this one you have permanent magnet, right, with rare and heavier generator structure. Okay, although it is small, it is heavier because permanent magnet is heavy. Okay, high initial investment, demagnetized problem. If you have fault, usually the permanent magnet become demagnetized. Okay, it lost its magnetic property. And also don't have flux control because you use permanent magnet. You don't have the rotor excitation control. Okay, current control. So no flux control lah. So this is the summary of the one that we discussed. So you can see here. Okay. Okay, this one I think is wrong. Make sure you check back this one. Okay. So okay, so this is squirrel cage, but it is in the type 4. Okay, I still don't discuss to you what is type 1, type 2, type 3, type 4. But later I will show you lah. Okay, so this is type 1, type 2, type 3, type 4. Okay, so wind turbine type 1 is basically this one. So you have a gearbox and induction generator. Okay, this one. And this one no need to worry, this one no need to worry. Just directly, the rotors directly connected to the grid. You can draw the gear, the generator just directly connected to the grid, the stator part. Okay, so this is the type 1. This is the old version, which is fixed speed. Okay, the slip can be only 2 to 3% only. Okay, so that is the old version. The type 2 is you have this one, variable rotor resistance. So basically the rotor you control the excitation current. That is the type 2. Okay, so you have a resistance, put resistance in the inner circle, not the outer circle. The resistance is at the rotor inner, outer is the stator. You have to draw two double circle. Okay, so that is the difference. You have more slip control up to 10%. So that is the advantage lah of using type 2 wind turbine. Also use the induction generator. Okay, so type 3 is actually the what you call, type 3 is the double fed induction generator. So this is the induction generator, this is the type 3. Okay, so the advantage is instead of using resistance to control the rotor current, okay, so you use a permanent and you use a power converter, and this power converter is usually smaller rating, which is cost efficient lah. So you have a starter, which is the outer loop connected to the grid, and the inner loop, which is rotor, connected to the cyclo converter. Okay, make sure you know how to draw cyclo converter. Okay, so this is the important part lah. And then the last one is the type 4 wind turbine. Okay, type 4 wind turbine is basically using either induction generator or synchronized generator, either permanent magnet or synchronized generator itself lah. Okay, so this one is just you have a cyclo converter here connected before to grid at the stator. So this one is 100% slip. Okay, you can use it as any speed you want. Okay, and also you can remove the gearbox. Okay, because you have a higher speed control. So this is the latest version, type 4. Okay, so this is type 3. Okay, you can see here type 3. You have a cyclo converter here connected to the rotor. This one I think is wrongly draw. Okay, so it should be inside. So this is type 4 full scale wind turbine converter. So this one, the power converter is much more expensive because it is 100% current rating, 100% rating power rating of the system, because all the energy is transferred through the power converter. So usually the question in the final exam asks you to draw the type 1, type 2, type 3, type 4. Make sure you need to know how to draw it. And also common question is the advantage and disadvantage of permanent magnet. What else? Double fed and this one. Okay, so this one sometimes they ask. Okay, one part of it lah. Okay, So you need to know all. Sometimes they ask you the speed, rotor speed for the fixed application and variable, gearbox requirement and generator type. Sometimes they combine together lah, 3 or 4 parameter together. Okay, so I hope it is clear on that. Okay, so this is type 1, type 2, type 3, type 4. No need to memorize all, I think. But basically everything that I explained before is summarized here. Okay, so for the next part is the power converter. So in wind turbine, you have a power converter in wind turbine. Okay, so there are two types of power converter used. Commonly either the rectifier, diode rectifier and boost converter, which is rectifier from AC to DC and then DC to DC. That is the common, or either way around lah. Okay, so this is usually bidirectional. Okay, and another one is the two-level voltage source converter. Okay, so this is basically a rectifier. Okay, control rectifier. This one is uncontrolled rectifier. So this is the commonly used. Okay, so you can see here you have MPPT here, and you have permanent magnet, rectifier, boost, and everything lah. Okay, you have a PI controller. Okay, MPPT set the target speed, controller speed control adjust the torque demand to meet the speed, current control fine tune the electrical current generated by the torque, boost switch control, and so on. Make sure you know how to draw this. Okay, so I hope you know how to draw this. Basically you have a rectifier, you have boost connected to DC, and then the other part is the based on the two-level voltage source converter. Okay, last time they have a question on drawing this and explain it. So this one also drawing and explain. I don't think you can draw this because it's quite complicated. I recommend you draw this one only lah. This is much more simpler. Okay, so last part of the electrical is the MPPT technique. So what is the MPPT? Like I said before, it optimizes the power generated lah. Okay, so determine the optimal operation of the different wind turbine speed, maximize the energy harvesting. So the MPPT used in the wind turbine is different from the PV. Okay, you can see here. So you have a tip speed ratio, okay, optimal torque and power signal feedback, control perturbation, and also this one also available in PV and other method. So at least you need to know lah the knowledge base and the iterative base. Okay, so for the knowledge base is you set the parameter, okay, and then you control the output lah, and iterative base is using using algorithm lah. Okay, so this is the type of method used, MPPT technique available. Usually we don't ask in detail. Okay, so this one basically the wind speed, wind turbine rotor against wind turbine power. Okay, so for this make sure you know how to draw lah. Okay, so make sure you know how to draw. Okay, if they ask the wind rotation versus power characteristic using MPPT lah, so make sure you know how to draw. Okay, so the characteristic should be something like this, and you have to draw the optimal power curve, this one. Okay, so this one also, when the wind speed is higher, you have to know how to draw this. Okay, make sure you know how to draw, label, and so on. Okay, so that's it for the electrical part. I hope you can understand. Mostly memorizing for this part. Okay, see you again in the next class. Okay, and also I would like to remind you, don't forget about the presentation assignment.